I am Arun Kumar from SS College of Technology in the Department of EC. In this video, we are going to see about differential equation in control systems. So the part of differential equation in control system is to identify the transfer function of the systems. This can be achieved by the following ways. Either it may be ordinary differential equations, partial differential equations, linear differential equations, non-linear differential equations, homogeneous differential equations, non-homogeneous differential equations. So these are all some types of differential equation, so that we can able to rectify and identify the corresponding control system functions. So because every functions having their own variables, so based on the variable only we can declare it in control system, so that we can get the concerned output signals. Ordinary differential equations. So this is the form of signal which has to be in first order. Example, dy by dx plus 5y equal to e power x. So e power x means either is it can be a single term, e power 0 or 1. So it can be eliminated by using a dx by dt plus dy by dt equal to 2x plus y. Next one is partial differential equations. So in this we can jointly combine together as two order functions, second order functions, dou square u by dou x square plus dou square u by dou t square equal to 2 into dou u by dou t. So like that second order differential functions has to be followed by using this partial differential equations. First order, second order, high order. So in control systems, there are three type of orders: first order, second order, and higher order. So based on the order, we can able to identify the corresponding differential equations. So for example, if first order, it has to be followed by first order linear order, exact equations, non-linear first order ODE, separable equations, Bernoulli differential equations. Suppose if your control system is a second order one, then it has to be matched with the following factors: linear second order ODE, homogeneous second order ODE, initial and boundary value problems, non-linear second order ODE, non-homogeneous second order ODE. Suppose if your control system is having higher order, means it must be satisfied with linear nth order ODE, because you are having more number of orders, so that we can choose nth order ODE, homogeneous equations, non-homogeneous equations, first order ODE. So general form of first order is dy by dx equal to f of x comma y. For example, in control systems, dy by dx equal to 2x plus 3. For first order linear ODU, it can be followed by poles and zeros. We can able to calculate the poles and zeros based on the control system variables. For example, dy by dx plus p of x into y equal to q of z can be solved by y equal to f of x q of x dx plus c divided by del of x. Something we have to insert in this differential equation based on the variable present in the control systems. Exact equations. So the exact equations has been modified by differential equations from m of x comma y plus n of x comma y into dy by dx equal to 0. From this we can able to modify the corresponding exact equations by dou f by dou x equal to m, dou f by dou y equal to n. Separable differential equations. So in this separable differential equations is calculated based on the variables, because if you are having more number of different variables present in the control system, then we can choose it as a separable differential equations. For example, n of y into dy by dx equal to m of x. So like that we can use different variables in this differential equations. So Bernoulli equations. So it is followed based on the order of the corresponding control systems. For example, y dash plus p of x into y equal to q of x into y of t. It's like that y power minus n into y of t plus p of x y power minus n equal to q of x. second order differential equations. So the name itself, we know that second order because the equation is having a second order. So it has to be followed by p of t into y of n plus q of t into y of t plus r of t into y equal to z of t. So the differential equation in the form of control system can be written by ay double dash plus by single dash plus cy equal to z of t, because it is a second order, so that we can choose it as a first one be a second order one, a into y double dash. So here the g of t d equals 0 be a differential equation homogeneous, and when the differential equation non-homogeneous equal to not equal, g of t is not equal to 0. Second order activity, so y double dash minus 9y, because it's a second order equation, so that we can able to choose the equations by y double dash minus 9y equal to 0. Applications of differential equations, modeling with first order equations. For example, it can be applied for Newton's law of cooling. Second one is modeling free mechanical oscillations. So in order to calculate the damping frequency ratio, we can use this differential equations. And next one is computer exercise or activity, modeling force mechanical oscillations. The oscillations are based on the number of variables present in the control systems. Linear and non-linear partial differential equations. So all the first order and second order has been combined by using this partial differential equations. It has to be followed by 2 ux plus 1 uxt plus 3 ux plus 4 ux plus cos 2 of t, because all the variables are present in this equation, so that we can choose the differential equation as same order. Laplace equations. So the Laplace equations are very useful to describe the steady state distribution of heat in a body, because steady state is a value which is used to finalize the corresponding Laplace transformations. By using this Laplace equation, we can able to see the corresponding uh, control function uh, as a correct signal received or not. So it can be called followed by dou square u x y z by dou x square plus dou square u x y z plus dou y square plus dou square u x y z by dou z square. So other variables are present in this Laplace equation. So based on the variables, it has to be followed the general equations. Assessments. Mention the example of PD in control system. PD are used to model many systems in many different fields of science and engineering. For example, it has to be very useful for Laplace equations, heat equations, and wave equations. Thank you.